Right, hi everyone. This is Kevin from Heuristics. It's the first time that we are doing this live streaming, so if there's any technical glitches, I seek your forgiveness in advance. Uh, Alright, I'm the curriculum specialist from Heuristics, and I've been here since 2011. So I also understand that prelims and PSLE is around the corner. That's why we've decided to come up with this live session in order to help out those who need it. So today I'll be covering on speed, I'll be covering on rate. I'll be presenting 4 problems. Hopefully you've downloaded the handout. If you haven't, you can go and download it first. So some of the examples that I'll be talking about will come from this book, the unit transfer method for speed and rate. So I'll be talking about the rate part, obviously, for today. So the issue with rate is this. Is there a systematic way to deal with the problem? The answer is yes. And there are a few ways to go about it as well, but I'll be presenting it by one way today. If you have any questions later on, you can post them in the Facebook post and I'll try to answer all of them. Okay, so since now it's already 8:04, let me show you what I've been looking at recently. So this is one problem that I came across in a group earlier today. Actually, it was around this week. This also. And this one. So there has been questions on rate coming up. I thought it would be suitable for me to do this. Okay, so let's dive in to the main meat of this presentation. Alright, let's talk about the first example. Let's start with something simple. An inlet tap. Okay, let me change the thing first. Okay. Alright, an inlet tap can fill a tank in 40 minutes. An outlet tap can drain it in 60 minutes. The tank is empty and both taps are fully opened at the same time. How long would it take to fill up the tank completely? Alright, let's start. Okay, let's look at what we have. You have an inlet tap that can fill up the tank in 40 minutes. So let's draw the table: inlet, time, and the tank. Okay, time here would be in minutes. And the tank would be compared in terms of the fraction. So this is 1 whole. Okay, so for the inlet tap, it takes 40 minutes to fill up one entire tank. For the outlet tab, it can drain this tank. Oops. It can drain this tank in 60 minutes. Alright, is everyone following so far? Okay, so the main thing in rate, there's one main concept in rate. No matter how you do it, it all revolves around one central principle. In order to make a fair comparison, the time needs to be changed to the same before any meaningful comparison can be done. So what do I mean by that? Now I want to make time the same, so I will multiply them to their lowest common multiple. So this would be, the lowest common multiple between 40 and 60 will be 120. To get these two to 120, your time needs to be multiplied by 3 for the inlet. So the tank progress here would also be multiplied by 3. Over here, this is multiplied by 2, so the tank progress here would also be multiplied by 2. So far, so good? So let me reiterate. This is the most important concept in rate. You need to make time the same. And how I did it by is to multiply them to their lowest common multiple. Okay, I'm sure right now some of you are thinking, why not make it to 1 minute? I'll explore that later in a while. So once everything has been made to a common time, we can say that the in minus out in 120 minutes will be 3 minus 2 to give you 1. So that means it's going to take, because this is your objective, it's going to take you 120 minutes to fill up the entire tank. Alright? Alright, so what if we convert this into 1 minute instead? Okay, let's explore. Okay. So when it goes in 40 minutes, it fills up one tank. So we divide this by 40. Not sure what's wrong. So now this becomes 1, the tank becomes 1 out of 40. Okay. For the out, in 60 minutes it clears one tank, so in 1 minute it would be in 1 minute it will fill up 1 out of 60 of the tank. Okay, so when you combine them up together, in minus the out, in 1 minute it would be 1 out of 40 minus 1 out of 60. So that will give you 1 out of 120. Alright, so in order to find one entire tank, you need to divide this out by 1 out of 120. And similarly, your time needs to be divided by 1 out of 120. So what happens when you take 1 divided by 120? You will get 120 minutes, which is the same as what was shown earlier. Okay, so you can see that for this working, it is done in fractions, and it will still give you the same result. The issue here is not every student knows how to deal with fractions. So in the UTM, for rate, what we do is we tend to make them into whole numbers to compare, because whole numbers is much simpler for P5 and even P6 to handle. It's something that they are more familiar with. So, oh hi. Give me a while, let me reply something. Yeah, thanks for being here. Okay, so next one, example 2. Tab A can fill a tank in 6 minutes, Tab B can fill a similar tank in 3 minutes, and Tab C can fill the tank in 2 minutes. If all the 3 tabs are opened at the same time, how long will it take to fill up the tank completely? Okay, so let's list out what we have. Tab A, the time, and the tank. So in 6 minutes, it fills up 1 tank. Then for B, it takes 3 minutes to fill up this tank as well. For C, it takes 2 minutes to fill up this tank as well. Okay, can I get some feedback on whether this penned ink is too light? Do you want me to change it to something darker? Okay, thank you, Lavana. Yeah, it's okay. Okay, thank you, Mohammed. Okay, then I'll continue on from here. So following the main central principle for rate, you want to make time the same for all of them first. So to multiply them to their lowest common multiple, between 6, 3, and 2, the lowest common multiple would be 6. Alright, so there's no need to multiply A out. We'll multiply B by 2. So its progress would also be multiplied by 2 because it is directly proportional. For tab C, we have to multiply this by 3, so now it becomes 6. And we also have to multiply the tank progress by 3. Okay, here is one thing that I missed out earlier because I was explaining the fractions way of dealing with it. Okay, some students, what they will do is when they want all 3 of them to be working together, they tend to take the time and add up 6 plus 6 plus 6. Okay, this is totally wrong because in the same time, all 3 of them are working together. Okay, this is what they call working in parallel. Probably it's not really described in primary syllabus, but that's what we call it. Okay, so this is one confusion alert you must take note of. It is only in that same amount of time, which is 6 minutes, all of them are working together. So A will be producing one whole of the tank, B will be producing two wholes of the tank, C will be producing three wholes of the tank. So in that 6 minutes, in this entire 6 minutes, all of them will fill up 6 of the tanks. Okay, so here we want to find out how long does it take to fill up the tank. So here you want one tank only. So to get to 1, this has to be divided by 6, and so must your time. So then we can see that in 1 minute, it takes them 1 minute to fill up the tank if they all work together. Then that will be your final answer. Oh, hi Judy. Don't worry, I'm only at example 2. Still got 2 more examples to go. Alright? And don't worry, I'll reiterate the main principles because those are the things that you really need to focus on. Alright, to deal with rate problems. Okay, so I'll move on to number 3. Okay, there are 4 taps in this problem, but don't worry. Okay, tap A, tap B, tap C, tap D together can fill up a tank in 4 minutes. So let's list out what we have. A plus B plus C plus D, the time it takes in minutes. And the tank Alright, so in 4 minutes they fill up one tank. Tap A and tap B together can fill up the similar tank in 14 minutes. And tap C alone can fill up the tank in 28 minutes. Okay, so for those who just joined us, what I was describing earlier is that in rate, you need to make the time common first, because if you don't have a common time, there is no fair comparison to be made. Now imagine if your boss say that you did 3 proposals in 5 days, your colleague did 4 proposals in 8 days, and your boss thinks that your colleague deserves a pay raise or something because he did more. So here is how you can justify to your boss that you are more efficient. Hopefully that's something relevant, okay, that you can connect with. Okay, so you need to make the time common. We'll multiply them out to their lowest common multiple between 4, 14 and 28. The lowest common multiple will be 28. So you multiply this by 7, this becomes 28. Your tank also needs to be multiplied by 7, because if you fill it up for a longer time, obviously you're going to fill more tanks. Alright, so then this becomes 28. No, this becomes 7. 1 times 7 gives you 7. 14 times 2 will give you 28. So your tank needs to be multiplied by that as well. So this thing here for C, there's no need to multiply out. Okay, so how do I find D? Now to find D, we can take the total of every one, A plus C, B plus C plus D, get rid of A and B, and get rid of C. So we can say that in these 28 minutes, A plus B plus C plus D, you get rid of A and B, which is 2, you get rid of C, which is 1. So then, in 28 minutes, D will fill up 4 entire tanks. Now for D to fill up one of such tank alone, it's gonna take them, you need to divide this out by 4 to give you 1. So we need to divide out the time by 4 as well to give us 7. So for D, it will take 7 minutes to fill up the tank alone. Okay, so that's the third one. All these are quite standard problems, but the emphasis that I want to make is that you need to make the time common, and secondly, when you compare their times, do not go and add or subtract the time, because they are all working in parallel. Alright, now I'll move on to the last one. For this I'll take a little longer. Tab A can fill up the tank completely in 6 hours, while tab B can empty the same tank completely in 4 hours. Bobby placed a cube of side 20 cm, so this is the cube, before filling half of the tank with water. The volume of the cube is 1/12 of the capacity of the tank. So Bobby turned on both taps at the same time. How long will it take to empty the tank? Okay, let's take note of something. He filled up half of the tank with water after he placed this cube inside. So the first thing we want to work out is how much water is there in the tank. So there will be half minus 1 out of 12, and that gives you 5 out of 12. Now if you want to know how to do this, we just convert this to the common denominator. So let's look at it this way. Tab A can empty the tank. Tab A can fill the empty tank in 6 hours, and tab B can empty the same tank in 4 hours. So intuitively speaking, tab B will drain out the tank faster than A can fill it. Alright, so how long will it take to empty the tank? Let's compare the rate between A, the time in hours, and the tank. Okay, for A, in 6 hours they fill up one tank. So in 1 hour, not 1 hour. Okay. For B, in 4 hours, what's wrong with my stylus today? In 4 hours, it can drain out the entire tank. So between 6 and 4, the lowest common multiple is 12. You need to make the time common to do a fair comparison. So we multiply this by 2, give us 12. We multiply this by 3 to give us 12. So when we do this, this becomes times 2. In 12 hours, A will fill up 2 tanks. For B, in 12 hours, it would drain out 3 tanks completely. Okay. So when you take B and minus A, okay, what happened? Okay, give me a while. Okay. So when you take B and minus A, what happens? In 12 hours, B will be emptying 3 minus 2, which is 1 whole of the tank. Correct? So now we want to empty 5/12 of the tank. So to get this to 5/12, we need to divide the time by 5 out of 12 as well. So doing this, we get 12 divided by 5 over 12. Okay, let me do the working here because I don't really have space already. 12 divided by 5 out of 12. So that will give you 12. Wait, no, this is not divided by 5 out of 12. Sorry about that. Okay, give me a while, please. Yeah, it should be okay. Here, this should be times 5 out of 12. So then 12 times 5 out of 12 would give you 5 hours. Alright? Ignore this. Sorry that I made some mistakes because I'm not really sure what's happening now. There appears to be some glitches. Sorry about that. So we've come to the end of our live coaching session. Do give me your feedback. And I'm not really done yet. Okay, let me show you where to download our solutions. You can go to our website, mathsheuristics.com. And you can check out this blog over here. Right? Okay, can you see it? I'll be uploading the solutions in a while because I didn't want to spoil the fun. And if you have time, do check out my YouTube videos as well. It's over here, very convenient for you to access. Okay, so let's look at how it's gonna look like. So once you've done that, click on this, and there will be questions and solutions. For some reason it's not appearing, but you can click and you can download here. The solutions I'll be updating after this session, and so give me about 5 minutes after I end this session, alright? So if you have any feedback or comments, do leave them in the comment section. Let me know what you all like to let me know what you all would prefer to hear about in the next session, which kind of topic you want me to emphasize on. Alright, thank you for your time. Thank you for having me, and good night. See you soon. Thank you for watching. I hope you've learned something today. Click here for more of such teaching videos and click here to subscribe.